And you're here just in time to watch me tell everybody else to come watch me, so let's just do that. I've actually prepared a bit of... Oh, I'm listening to myself tell you to come watch me. Let me just, you probably can't hear me tell you that I'm listening to myself tell you, but it's very distracting. Oh, let's just turn this off. Okay, that's better. Fantastic. Wonderful. And finally, I need to just pop into my Discord, where I'm sure you're about to come, and tell everyone here that I'm going online. Yes, and wonderful. Okay. So I'm starting about 2 minutes earlier than I was planning to, which is lovely. Got some licorice tea there to enjoy. Sound looks okay. Good. Let's get cracking. So, what are we up to? So what we're working on at the moment is some procedural generation. I've got some meshes here. There are a few problems you can see. For instance, the sides have got holes in them and so on. These meshes are here in Godot being made by Rust code. Let's get across to the Rust code here. And the Rust code. Now, I know the reason why there's holes, and the reason why there's holes is because we've got a problem with backface culling. Let me just put this window here. Like so. And then I need to change the size because I have it so fiddly and tiny. Settings, font, size, put that at 16. Stream is live. And make sure that that is this link. Doop. Save. Wonderful. Okay. So this procedural generation code, sometimes it's making this triangle strip. I might explain it in more detail when there's more people watching. Let's just wait a little bit. Okay. Running here. We've got a triangle strip being created, and it's being created by... Where is our code? Basis. Hello, transform. Okay, we don't have it open. In fact, I've got the wrong project showing at the top here. So let's just close that one because it's going to confuse me later. Here's the project I meant to show. Hey, Togglebit. Hey! I love the way you do that emoticon with the circle slash like that. So here we're making a whole bunch of triangles in a triangle strip. So we start off by pushing a bunch of vertices. So they are the vertices you see in the asteroid. And as we go down a bit further, the order in which we create them is important because each second triangle reverses the order it expects the vertices. So the first triangle is like this, and then it takes those two, and we put one more vertex here, and so that means the second triangle is like that. And so in order to figure out the backface culling for each one, what it does is it reverses the order. So the first triangle, it goes I think clockwise, and then the second one, it goes anti-clockwise. So it's important to track because we need to either put the vertices this one then this one, or if we put them around the wrong way, that one and that one. And if you put them around the wrong way, you end up with these ugly gaps. So as you can see here, you got some... This one here is correct. So what we should see is we should see these sides, and then we should see a hole underneath. There's no reason not to have a hole underneath because I'm not going to have the camera down there anyway. But these sides at the front here are a real problem. So, and that's because we've got the triangles around the wrong way. So I came up with this idea just before I came on where I could use this try strip next reversed to tell me if I need to reverse it the next try. I've already got the code to reverse it, but I'm tracking this. The way I figure out reverse is a little bit flaky. So I do this reverse equals not reverse thing, which works for those ones. Where's my problem? Oh, that's my problem is my loop. So once I start making loops which go around and around the asteroid and go down, I'm going to need to do something slightly different. Hold on. Left loop, right loop, and then we go through them one more time and we create the borders, which is great. That's all the vertices we need. And then here we create the first strip, and it's at this point that I need to add a piece of extra logic. So if it's reversed, if the skirt is reversed, we need to go back the other way. So if the strip is currently reversed, we need to add one more vertex, which is going to unreverse the strip like this. Well, it's probably clearer if I put that there. And then, so this is all in the name of creating something called a tri-strip, which is a really packed way of making a bunch of triangles all at once. So we need to repeat that index one more time. I need to find where I was before, which is up here somewhere. So we're going to get out of this proc gen pretty soon. But this is the stuff that's wrapping around the asteroid. So let's see if that works. So my current build process is I need to quit Godot because it's holding my DLL. So let's just quit that. Exit. And then I need to rebuild my core. So my my core DLL, which is this project here, is the one that Rust is loading. SG core is the one that Rust is loading. So we need to rebuild that like so. And now we're going to find out if the whole asteroid goes invisible, which it will do if I've messed up my sequencing of things. I've got a lot of windows open from all sorts of things I've been doing on this computer recently. Okay, Godot. So just earlier today I set up my asteroid logic, which launches this. Oh, okay. So I think I've got my reversed backwards. You see how these top ones, this top mountain range is all, you can see through it. Backface culling means it's getting rid of the triangles. It's supposed to get rid of the triangles on the wrong side of the mesh. Because all the triangles are around backwards, it's getting rid of the triangles on our side of the mesh. So what I need to do to fix this problem, I've got my ones on the top reversed. So probably the easiest way to solve it is to go up here to the start of my logic, where I first get this reversed, and I need to swap this logic around. So if not reversed, it does this, and that will switch the computation around. So let's just restart with that setting. Quit, rebuild. Good morning, Weird. It's nice to see you. Thank you for joining me on the stream. Weird Constructor is making space something. SSCG or something. I keep forgetting the acronym. I wrote it all out for him earlier today. What are you making? Yes. So we're just making this space. He just made this model. Let's see, what's it called again? Spaceship cargo game. That's right. It's inspiring to people making cool games. Yes, spaceship cargo game. You'll find a better name. I mean, you'll find that my repository is still called Space Factory or Star Factory. Here it is. Anyway, I'm sure you'll find a better name, or a name you like more as time goes on. Okay. So I reversed that, and I was just going to launch Godot again. So now my star clouds haven't got holes in them. So when I was first working on these, I only could see the camera view from one angle, which was on this side. Was it? No, I think it was on this side. But now that I can move the camera, I can see all the little glitches that are in these. So, although it's probably going to be very tedious to watch me struggle to fix those, so let's not worry about that just yet. So there's a few things we need to worry about. First thing is I'm going to launch Steam, because time for games. Well, technically I'm doing time for games at the moment. Yes, toggle bit. My chroma key is set the same color as my top. Blame weird constructor. I hope you don't find it too off-putting. It's supposed to kind of be funny. Anyway. And then, of course, got to put my sound meter in that part of my screen so you can see how full of hot air I am. Start in offline mode. That should allow me to do this. And I'm just going to launch Substance Designer. Oh. Great. Let me just this guy, small left. I'm going to hide that screen just for a moment. I'm just using a password manager to get my Steam password and log in. Great, and into Steam. Copy. Steam. Change account. Log out. So what we're doing here is I'm just going to log into Steam as my corporate account. And on that I have an important tool, Substance Designer, that you're about to watch me use. Close and get rid of this, and then Substance Designer, launch, and then I'll just get rid of this one password again, block, hide that, and give you my screen back. There you go. Excellent. So with Substance Painter, so we've got two things to worry about. First one is I don't think I've got a texture. How would I make a color texture? That would be one way to do this, but there are advantages of doing it straight up in Substance Designer. Something is locking here. I can't tell what it is. There's something dinging at me. Substance Designer's put a helpful little dialog on the other screen. There we go. Okay. Here we go. So I'll open up a recent project that I worked on to do with rocks, or gold. So if we start with this is a texture for ground. Oh great, it's gone and lost itself on me. I'm not quite sure how, and I'm not even sure how to reset the camera. Focus. There we go. So this one is like a ground texture, but I also created some different kinds of resources. So flexible ores. So for instance, here's gold ore. Now, what you see here looks a bit odd, and the reason why it looks so odd is because it's designed to fit on a bunch of little asteroid rocks. They have these little meshes. I think I even had the mesh here. Resources, ingot. Where did I put the mesh? Because I had it as a... I really thought I had the the mesh is a resource here. Anyway, I'm getting distracted. Thanks, Sam. Wait till you see the rendered one. Okay, I might just see if I can just drop the actual model directly from my work into here. Code. Nope, wrong code folder. Game dev. Star Factory. Blender. No, it's in game, and then from here we had 3D space, and yes, it is a mesh, and it's, I don't know if we could use a GLB file. I think I decided that I couldn't use that directly in Substance, so then I had to use it, where did I put it in Substance? That's right, that's a Substance file. No, blend. Shape drafting, rocks, FBX, was it FBX files that worked? Yes. So this is what the ore looks like, and it's what it's been. No, that's not mapped properly. That can't be the right one. Let's try the latest one. Rocks HQ is probably the one. Oh, it must have been a larger model. 10 megs. Why did I make a 10 meg one? Anyway, this is what the texture looks like when it's put on. It's put on my nicely. So and it's not just gold that we've done like this. Let's have a look at a couple more. So here's iron. Here's nickel. Here's cobalt. And so in every one of these options, I've got some parameters. So for instance, if I go into my material, my flexible ore material, I'm not quite sure where to stack up my 3D view since I'm sitting here and talking to you on stream. I'll just, because normally I put on my other screen, you see, and in addition, not that it affects you, but the screen I'm currently using hasn't got very good color, so everything was washed out to me on the screen. So if we choose a particular asteroid, now it's worth noting that up till now everything in my game has been like really tiny, so I could easily change the resolution of this to a higher resolution. It looks chunky, but it doesn't have to. I mean, it's going to look more like that than is the other option. Anyway, on flexible ore, I expose some parameters like how much metal there is. You can just crank this down, or up some more, or up some more. You can change how dirty the rocks are or clean. Make them clean still, or make them very, very dirty. So, and it's a real pity. Like this is one of the hard things about working in Godot is that there's no plugin to do this. I could do this in game if my game is in Unity, because there's a Substance Designer plugin for this for Unity. So, but I still think that Godot's the right choice for me, despite that. So what I was hoping to do was to take this. The way this works is it has a particular map of coordinates. This one here is a normal map of the surface. I've done all this work inside my flexible ore to actually take the model itself into consideration when designing. It should be loading this now. I'm surprised. Is it that I couldn't go straight into it that way? It's taking the design of the material into consideration as part of the inputs, and so all the noise is based on things like position and so on. And so on, the first thing we're going to have to do is actually figure out what inputs we want to use. Yeah, Sandmake's Games is right on the money. So that's the plan. The plan is actually to bake out several textures that are related to different ores, and then to blend them using a shader once they're inside of Godot. So I want to make sure that if I had a plane like this, so at the moment you can see all the asteroid shapes, and it makes more sense if you go into Blender. So Blender's loading on the other screen, and I'm just going to open and jump to that folder I showed you earlier. Just in C drive and go to the right folder. Nope, this is not the right folder. Game dev, Star Factory, blend, shape drafting, and it's inside of rocks. So if I just show you these rocks here, and I select all these rocks, so here's all my test rocks, and look at this. You'll see the UV mapping is like that. So when you see this UV mapping here on the right hand side, and then you compare that to the text you see here, you start to understand that each of these different shapes you see here corresponds to a particular area of that. They're not very easy to tell. Oh, thank you, Windows, for making it full screen. I really appreciate that. So you can kind of see those regions at the top here. Or if I looked at this one, yeah. Anyway, it's probably enough detail. I should probably stop blabbing about that. Okay, so ores. We've got a lot of various ores, and in every case, it's taking as input. It's taking as input these maps. If I wanted to get different ores out, I'd have to copy these. So, I wonder if I can just copy the whole lot. Grab this folder, copy it, paste. Yes, and it's made this folder called ores1 here, and then in ores1, so this one is going to be flat ores or something similar, and let's just choose a couple of distinctive ones. So we're going to start with the gold ore, and so I essentially need to replace each of these different things with some flat stuff. So or flat color, or color, yeah, it's probably called uniform color there, like this. So uniform color, it's grayscale, so I want uniform gray. Oh, what would it be called? Because this position bitmap needs to be, I wonder, did I set up a default for this? What if I don't have a position? So how did I manage no position in here? So I basically need a position bitmap that has everything in it. I wonder how I can do that. Ugh, almost sounds like shaders. See, you're running against my knowledge of this particular program. Something about being on stream that makes this all far more intense. How do I replace a position image with something that's just X and Y? Let's Google this. And yeah, I probably need to create my own thing for this, and it could be quite annoying to do it this way. So everything is position based, which was a really good idea at the time. So is it's like pixel processor, right? But not that, it was another one that was similar. FX map. It was basically a pixel processor, I think. And it needs to evaluate a function per pixel, and the function we needed to can't remember how to actually edit this thing. Per pixel function, here we go. And if we were to look at the other thing, it was going to be something like x position Cartesian, or how do we get the current position? Yeah, this is going to get really annoying, isn't it? Okay, let's have it as read that I'm going to solve this problem, and I'm going to do it offline so as not to bore you guys to death. But I was thinking what I'd do is create a function that outputs, blue across the bottom increasing, red across a side increasing, and that's basically the position bitmap, and then feed into all these places. Some of these things like normals, we just want a particular shade of purple, that sort of thing. So each one of these I'd make a mock-up for it. It probably would take me about half an hour, and then I'll get out a gold map that's completely flat. But in lieu of that, for now, the really hacky way of doing it is going to do this. So what we're going to do is we're going to create a new model. Check this out. File, new, general. Don't save rocks. Okay, we've got a cube, right? I don't really want a cube. My pillow's not quite that big, so we'll make it a bit smaller. And we're going to delete the bottom, so tab, we don't need you, bottom, delete you, delete faces. Great. Okay, so that's what the asteroid looks like, and then we're going to go to select 2 and unwrap you. Control E, mark seam, mark seam, mark seam, mark seam, save. In shape drafting, we're going to call this bulletin plate. Doop, save. And so this is like my asteroid stand-in. And having done this, I can now select everything and unwrap it. Unwrap. And then I can go to UV editing, and that's how it looks on the UV map. But that doesn't match the way that I think about this. So let's select this, Control L for all link nodes. What? Yep. Grab. Looks like it's rotated by 45. And then what we're going to do next is select these ones, and we're going to scale them to by 1.25. Okay, let's scale a bit more. So let's select them all and scale it by 1.5. Yeah, scale by 1.1. Whoops. Scale. So we're going to scale by 1.6. Good. Okay. So that's the box in UV coordinates. So as we go across the bottom here, that's U coordinates, and then go up the side here is V coordinates, and then some of the boxes outside of that. So we're just going to bring these in. So we probably can do this, and then scale. Yeah, nice. Yeah, I can't get it to scale the way I want it to. So we'll just select half of it. Scale X, bring those in till they touch. So they should be just inside. We'll just scale them in just a tiny bit more. X. Yeah, that was kind of the plan. But then I realized that I could actually just do it this way. And this way is more real, so it works for me. So here's the box. So this is a stand-in for our asteroids that we're going to be making in a minute. Save this guy. I don't like that I messed this one up so differently. So scale Y. It's going to bring this down so it's close to the edge. Okay. So this is now an unwrapped mesh. Save file, and we're going to save this, save as, and actually I need to export it. Export as an FBX file, which Substance Designer can open, and I think I called it pillow. Yeah, I called it pillow template. So an FBX file, export. Okay, that's great. So what do we do with my pillow? So we don't need that for a second. We go back across to here, and we've got a pillow template FBX file. So there it goes across to here. That's my pillow template. Because it has no plane underneath, and we've got backface culling turned on, when you look underneath, it's just like my asteroid I showed you before. Now the next step is to take this guy and pop him in our resources. Oh, that's right. So if I wanted it on the right, I probably just double clicked it here. Yeah, that's what I was supposed to do before. Remember when I was struggling? Anyway, so we've done this, and we want to bake model information. So here's all the baker stuff. Preset. Did I have a preset? This looks like a legit preset. Height map for mesh, world space normals, curvature. Yep, that sounds like the stuff I did last time. So, and there was a button to push. Oh yes, I need to use the lowest high resolution. Start render. Not surprisingly, it shouldn't take too long to bake this. There's that picture that I was hoping to make with the shader. And now we're ready to texture our pillow. So these 5 here, I want to bring across my pillow. So we've got a normal map. Not surprisingly, it's very flat. We've got a position map. We've got normals, and we've got a height map, which is odd looking, to say the least. And now we just need to plug each one of these in like this. Doop, doop. And I just need to, it's funny it won't pick that up. Let me just run that this way then. Doop, and doop. And which one's this one? Oh, ambient occlusion. Is it the ambient occlusion? Yeah, where's our... Oh, there's our ambient occlusion. For some reason it didn't come across. Okay. Which is self-shadowing, right? So let's turn on this ore. Yeah, that's interesting. I was expecting to see something on the right hand side here. Good. Okay. That's what we're looking for. So we can get rid of all these. We'll get rid of these things, these images. You can see I'm not a Substance Designer expert. I'm just good enough. Okay. So this is what my gold texture looks like, my gold brick. Doesn't look too bad. Actually, I could live with that. And then the next one, let's have a look at iron. So for each one of these I'm going to do something very similar. Iron ore. Grab these, put them over here. And go back up here and bring across the various, I don't know if I can just select them all and then bring across at once. And then I still have to redistribute them. That one goes there, this one goes here, this one goes here, this one goes there. That one's the normals, that one's the, I'm not sure what that one is. It's curvature. Did I even use curvature? I don't think I was supposed to use curvature. Oh well, I'm going to get some interesting artifacts on the gold one by using that. And then anyway, move these across. Let's try that again. Okay, this time that one didn't want to move. What to do it by hand. Here we go. I should be showing you the output as it goes. Let's just put that over here. And then this one, which is positions. So as I change each one of these, it's updating like a procedural mesh. It's a procedural texture that's being created. Delete. Now, I'm not sure I've got something that, does my granite ore, what does that look like granite? That was quite pink, wasn't it? Yeah, there we go. What looks like granite? What looks like rock? I probably have something that looks like grey rock somewhere in here, or I might have put it underneath one of my other ones. Quartz, yeah. Nickel's probably the closest I've got. Yeah, Substance Painter is better at rust than rust is. Let's say that this is, let's say the nickel. So what we'll do is we'll copy the nickel and we'll set the metal quantity very low and we'll just call that plain rock. Rock. Plain rock. Right, and this will, to save you guys the trouble of watching me do this too many times, this will be the last time I do this, I think, and I'll do the rest of them offline. So, polymap normal, polymap position, polymap don't need the curvature, world normals is this one, height map is that one, no, and what's the top one? Ambient occlusion. Excellent. Okay. And we'll see if we can transfer these again. This position will make the biggest difference when it's working. Odd. Hold on. Yeah. Something funny is going on here. Why is this not showing as updating? I think I'm not showing the new nickel. That's why I can't see a difference here. There we go. That's what I was looking for. Okay. That's good. So let's just get rid of these old ones. Delete. Move this across. So at some point or another I probably should run a stream just to talk to you guys about this program, because I really love me some Substance Designer. All these ores you see here are made from scratch based on, I started off with a tutorial on how to make some dirt, and from there I grabbed some references and made lots of tweaks and had lots of fun and ended up with all these materials. So I could spend all day in here. It's like, I could probably happily spend a couple of months just churning out textures in this program. It's quite a lot of fun and it comes up with stuff that looks really nice in my opinion. So, we probably need to do quite a lot to make this better for as being the base. I need to get rid of the metal. I need to add some more rocks to it. All sorts of things. So we might just make that, what we'll do is we'll make it less metallic. So in this one, we're going to reduce the amount of metal quite a lot, so that, and we're going to, okay, that didn't do that. Maybe, yeah, some reason that one was reversed. Make it certainly dirtier. See what these things don't seem to be doing much to the picture. I think I got my metal. I think I got my metal and my. Oh, that's looking interesting. And background reversed. I think I decided that the background of nickel looked this kind of golden color. Yeah. I got it especially off. I don't know, some sort of audio web shop. It always looks like this when I'm walking around. Yeah, it's nothing to do with chroma key. Nice to have you along, by the way, Carofel. As you can see, this is totally Rust and not me trying to figure out how to make textures. Let's have a look at some of my other materials. That's my slag. That's my quartz. Cobalt. Nickel. Iron. Yeah. I don't think I made a rock that's appropriate for rock. It's great to see you. Okay. How about we just quickly modify my shader to make something that looks okay for rock. So we're going to my flexible ore. It has a lot of stages. It creates a bunch of noises. It understands the mask of where metal is. It creates a lot of speckle. It goes down here and splatters some shapes like rocks and stuff, which is what's used to create the metal. So let's just start by in order to make this, in order to add a new kind of metal, I have to go to this multi-hub switch color, and I need to increase the number of inputs it's allowed to have by 1. And then I need to activate the background, and in here there's some way of changing the number of parameters, I think. It was metal type. Yes, this one. And I had to add one more to this group somehow. Add item, and we'll make it number 9, and we'll call this asteroid. My start menu, I can't remember what the name of this program is. Okay. Oh yes, it's on my suggestion list. It's called Quadro. So it's loading a little program called Quadro that's bringing up a lot of art assets. So for instance, this is an actual picture of actual gold that I use as a reference for my substance for gold. So let's do a quick Google image search, shall we, my friends? And reveal everything that I do. Let me just get rid of that until I've actually written in a search. Oh, I think I already downloaded some references for asteroids. Images. Okay, so here's some images of asteroids. That one I found particularly interesting. This one's pretty interesting too. I think this one's a bit blurry though. Yeah, and it's too stylized. The pictures are not, the colors are not very good. This one was pretty cool. But again, the colors are too stylized. It's really nice that you could drop by the way, Careful. Thanks for your help with GD Native. This one, it's very black and white. I know that's the color that's probably, it could be partially to do with radar, and it could be partially to do with that's the actual color of asteroids, which is a pity because it looks boring. This one looks more interesting. Yeah, I'm trying to find something that speaks to me as asteroid. Yeah, that one's a skull. Okay, totes. Oh, I like this one. Awesome, and it's an actual picture from an actual asteroid. You can't get much better than that. Okay, so let's download this one. I wasn't downloading anything to do with ASP.NET. Trust me. Save. Where are we? Save image as, and I tend to put them in the same place, which is in pictures as a reference. OREF. Let's just put it in OREF. Oh yes, and .png. Wow, I was taking a while to download as well. Yep, it opens okay. So next thing to do is to find the Quadro icon down here and say add local image, and oh great, now I'm showing you more personal information. Pictures or ref. Asteroid ref. Says I can't open it. Okay. Open containing folder. Interesting. Is this not... Did I not actually save an image for some reason? View file. Save. Pictures asteroids. Or... try this again. I'm starting to get a little bit frustrated at trying to do the same thing 1,000 times. Please forgive me. Okay, that seems to have opened. Let's try doing it again with Quadro. It's very stressful doing this on stream. I'm sorry it's taking so long. Quadro. Open image. Add local image. Work. Okay, it doesn't want to open. Fine. I'll just view it in this other viewer that seems to be happy. And I will ignore the fact that I don't know why Quadro is not opening it and proving how cool it is. Great. Let's move on. So, I've got this great little reference image. See how it floats over the top and doesn't have any border, kind of like all these other ones do? Yeah, but we can't do that right now because maybe PNGs aren't supported. Maybe this file isn't supported. I don't know. So, the reason why this is important usually would be looking at this and trying to copy details from the image into our texture creation. We're going to be using it for a swatch in a minute. So I've got a number of setups here. Let me just grab all these and move them up slightly. No, didn't mean to grab everything. Let's try again. Grab all these. This part is the part where it's like I've got so many different materials. I've kind of been data driving part of it. Is it going to move them all together? Yep. And then this one here is connected to this input. So what's going on here is that I've got a whole bunch of processing that goes through here, and it creates, from the input locations, which are on the far left, it creates a bunch of interesting noise, and in the end creates two different textures. So the main two textures are here and here, based on the two different noise parameters, and those textures define for metal and and background respectively what the backgrounds look like, and then we splatter a bunch of rocks and stuff all over them, and we run them through a little process, and when we're done doing everything we can think of to make them interesting, so here and here with see little white dots and stuff, we come up here and we split out the metal and non-metal, and then depending on the kind, we then take those black and white images and we turn them into color images. So this top one is metal and this bottom one is non-metal. So if I just change this to say rock, then we need to come up with colors for both of these. Now the easiest way to come up with colors is to pick gradients off your image. So I've just clicked this little pick gradient. I'm going to go across to my image on the left hand side here, and I'm just going to, I might just do a bad version of it. We'll do it again. So I'll bring this over here, pick gradient. See, this is why good things can happen to good people. I'll just move this out of the way. Let's try that again. That floating Quadro thing fixes these problems, you see. Before I pick gradient, I might just zoom in a bit. So let's look at this picture. It's not zooming in. Okay, where's an interesting area that's not interesting? Let's say that an interesting area that's not interesting is over here, so we find a dark area. We go to a light area. This is generally how my noise works. We get those colors out of the asteroid, right? And here for the asteroid itself, we need to choose metal amount, and it seems to be cranked way up at the moment. What's going on? Metal type. I need to tick asteroid, and then I need to say that flexible ore is the one that's being output here. There we go. This is better. This is a preview of what I'm creating, as you can see how the background is that same color as the asteroid. We're still using the position that we had from before, but then there's metal patches on it. I'm going to hijack the metal for this one and say that a metal is like a bunch of rocks or something similar. So maybe the more metal, the more it is a rock. That would work. Yeah, I know, you used to take photos. Who would do that? And you still can, but the thing about this is that you can data drive things a bit better. It works better for most stuff, but the way we're using it here is probably not the best. What's really nice about this approach is that actually all the textures are going to be very similar, but different colored. And so when I blend, the details are going to kind of blend together in an interesting way. Yeah, it's going to be the one. Just take my word for it. Great, I've never led you astray before. Okay, a rock. Let's see how rocky it could be. So let's just pick a gradient and we'll start here and we'll just go like this. And the only other problem now is that the rock bits look metallic, right? So if I get rid of how shiny that looks, we should be there. So, and I think that if I was to save this and then go back to plain rock and put plain rock on here and then go into flexible ore, so let's just put plain rock back over here. I'll put this, my artistic inspiration, on the left. So if I was serious about this, I'd spend a lot more time with that artistic inspiration, trying to create each of those kind of rocks you see here and make sure that they're in the material and that they get splattered around and, you know, that sort of thing. It would be good fun. Oh yes, metal roughness. I need to make sure the metal type here is set to asteroid, and then metal roughness needs to be nice and high, so it's not shiny. Height noise. I can't remember what that slider did. Oh well. So yeah, doesn't look that great yet, does it? I'm going to need to add a lot of doodads, gizmos, that sort of thing. I was going to quit Quadro because it's filling my screen with beautiful imagery that's distracting me from seeing. Well, maybe I'll just put the stream summary somewhere else. Let me just see if I can find it while I mess with you guys while you trying to view. Why would you want to watch what I'm doing? There we are. It's my stream summary. See that I've got 6 people captured 6 minds and souls. Excellent. It's good to know it's not a scary number. I wouldn't want to be too popular. Okay. Where were we? So we've got plain rock. Let's have a look at gold ore. Let's have a look at iron ore. And let's just say that those are the only ones I'm going to use for now. And so for each one I can right click and I can say export outputs as bitmaps. And for my outputs in Godot, so I'll just run you through this real quick. So we'll just go back to gold because that's what I'm looking at. So with gold, it outputs. You've got your base color coming out. This is, I'm sorry, I said gold, but I'm still showing plain rock. So we've got your base color, and then you've got your normal, which specifies on the surface which way it's bending. Yeah, I need to stream in. I need to stream at a better time for people in the US, like at 2 p.m. or something similar. I'm not sure I'm going to manage that. It's got a roughness map, which specifies which parts are smooth. We've got an ambient occlusion map, which specifies self-shadowing. A height map, which is kind of irrelevant, pardon me, for this. In fact, we should be seeing a lot more noise coming out of the height map. And part of the reason why is because I need to amp up the noise coming out of this material. It's very much designed for my pre-baked asteroids. Anyway, so then what I do is this merge, this RGBA merge, and I create something called an RMA height. And so the red channel of this image is roughness, the the blue channel RM, so RGB, so the blue channel, second channel is metallic, third one is ambient occlusion, and the fourth one is a height map coming in. And then I've got also separately a normal map and a base color albedo. So when I'm outputting this image, output as image, I need to output the height, the RMA and height, the depth map, and the base color, and the normal. We're not using the depth map right now. These are enough to represent everything about the material. So let's check that this is in a good place. 3D space material, PBR, yeah. We'll put them in another folder for flat. And export. And then we're going to do the same thing for each of these. So iron ore, export outputs as bitmaps. This one's going into a different place, which is actually in the wrong place, which is the place that it's caused problem in the past. Materials, no, material, PPR, flat, this folder. The right ones are selected. Export. Great. Plain rock. Export outputs as bitmaps. The right place already. Export outputs. Exporting. Done. So that Substance Designer is done for today. I bet you guys are glad that that's over and done with now. So let's have a look at Star Factory. We'll go into game, and we'll go into 3D space and materials. I went to the wrong place. Material, PBR, and all these images you see here are old. These are the ones we just created. So we've got a gold ore color map, a depth map we're going to ignore, a normal map. This is the color for the iron. Depth map we're going to ignore, a normal map, height map we're going to ignore. Oh, I didn't actually get rock out. So for some reason when I did the plain rock export, export as bitmaps, I didn't get those. I still didn't get them. I probably put them in the wrong place. I probably didn't put them in the flat folder or something. And here I was telling you it was done. I hope that watching me makes you feel better about all your own mistakes. Close. Plain rock. There we go. They're rocks. Okay. So Godot helpfully puts a bunch of other info files in the same folder just to process those. It's just processing all those images. So now what you'll quickly find out, if I was to select one of these, in fact I can't even select them, if I was to set them up with a material, they would not even be UV mapped. In fact, that's kind of breaking my head right now. I need to set up a mesh. Okay, so here's what I'm thinking. These things you see here are actually mesh instances, but they're not an array mesh themselves. And because they're not an array mesh themselves, they haven't got a script on them, and even though they're tools, when you look at these, this isn't the actual node, it's the node that has a child. So I think there's a bit more Go.script work to do. Quit. So let's just go back in here and go into GD asteroid. How are we going to go about doing this? Might be even easier to modify the wonder if you can put a script right onto an array mesh. Let's just run up the engine one more time real quick. So here's what I'm thinking. I'm thinking that if I want to start playing around with the settings for this mesh instance, I need to, this is a script I think on a spatial node. This asteroid test is actually not a, it's a spatial node right now. I'd like it to be a mesh instance node that has a script on it. So add a child node mesh instance, and then make this one with the script, because mesh instances is the one which has materials and overrides and that sort of stuff. Yeah, and I want to move this script here onto the mesh instance. So I'm going to delete from the scene these three guys, and then I'm going to save and quit, and then I need to go into and there are warnings that we shouldn't change tool scripts too much. So what we're going to do is we're going to change asteroid right now. Asteroid is a tool class, so we're just going to make asteroid a regular class. So the reason why it's modifying Godot is because it's a tool class. So we'll change it back to a regular class, and then I'm going to make asteroid. Right now it's a subclass of spatial. It's going to be a subclass of mesh instance. Hopefully it doesn't require me to change too much. Owner was currently a spatial, now it's a mesh instance. So in a lot of places where we see spatial, I need to use mesh instance instead. Mesh instance is now a mesh instance. And then here where we try and get hold of a mesh, we don't even need to do that because we already are a mesh. So rather than calling this owner, we might just call it mesh. Let's rename that to mesh, and replace, go up, we'll replace all. Okay. So now that this is a mesh instance, that means that when we create an asteroid, we're creating an array mesh and we're attaching it essentially to ourselves, as opposed to creating a holder for it underneath us. So that hopefully should be a little bit cleaner. Now the next thing I might do is just find the code for that. So the code for that is in stardev star factory, and in game, and then in script. And in script I have native sim, and then I have asteroid.gdns. I'm just going to have a look at this file, and it thinks it's a spatial. It doesn't even have it written down here. No. So I don't need to change the native script class. That's good. Okay, so let's launch Godot again. Oh, I need to just compile this real quick. It's probably not going to compile. We'll just see. Mismatched types. Hey, Wardley, thank you for raiding. Nice to see you guys. Welcome. It's I don't know, you streamed as well. I'm just modifying my GD native script for Godot so that my asteroid generation is a mesh. I think somewhere in here I've messed this up. Well, where have I put a spatial? Where I should have put a mesh instance? This one's still taking a spatial. Any more? No. I'm very well, thank you. I'm pretty excited about getting to shaders, but I've just got stuck in other details for now. I thought it'd be fun to try and stream it only half prepared. It's like, well, why put it off any further? Okay, so that compiled. I mean, I gotta keep remembering that failure is part of the story as well. Okay. Let's see if I can bring my space cushions to life with with this new script. Oh, it won't appear. It won't appear in the tool anymore. It'll only appear when I launch the game now. So, and the reason why is because it's no longer a tool script. So, which is, it's called asteroid, and we're going to add a script to it. But it's a native script, inherits from a mesh instance, uses asteroid.gdns, but that's not the right one. It needs to be, where are we? Script, native sim, and asteroid.gdns file. This looks good. Load. Okay, and so now if I run the game, oh yes. Okay, so I'm very happy that the mesh is showing up, because that means that my Rust code is still creating a mesh directly inside the mesh rather than creating a mesh to hold the mesh. That worked so well. Procedurally generated Weetabix. I love it. Since that works, I'm going to, with great confidence, go back to lib and change this to add tool class again, which will mean that the transformation to a procedurally generated Weetabix is going to happen in the editor itself. I have to quit to project list. Yes. Now rebuild this. Wonder if I can right click on you and follow you wildly. Add. And I see a button here for follow. Whisper. Following. Yeah. I don't see a way to follow you. Dot? No. Oh yes, there we go. I can now follow wildly because he so kindly raided me. I think I just have to follow him back. It's the only thing to do. Anyway, yeah, I think most people don't have a channel, and so they thought there's no point putting a follow button in there since most people you'll see in chat don't stream themselves. There we are, Space Weetabix. Now, if you've missed this already, because you haven't seen me do it, but if I click on my Space Weetabix, that's the wrong one. Asteroid. There's actually, it should be test. I can change the seed, and changing the seed changes which mesh gets generated, like so. So we're getting pretty close to being able to use this stuff here in the editor, but I'm sorry, there's still another major step that needs to be done, and that is I haven't got any UV mapping on my mesh yet. So if I was to assign a texture to it, you wouldn't be able to tell. So what I should be able to do is set a material override here to be a new spatial material, and we go into the override and we go into the albedo, and then we're going to start grabbing some stuff off our file system. So let's look at our file system. In fact, I might how do I move this? Let's drag. No, but I push the dots. Yep, so we're doing a docket on the right hand side next to this one to reduce the amount of dragging required. And then I'm going to try and make this whole editor a little bit larger so that you guys, get more pillow from space. By the way, in case you haven't figured out what's going on here with the pillow from space, is that this is a height map. It's drawn like this. So we choose some numbers for the height map, and we make each node as high as we can, and then we go around the side and we draw like a little shape, like a skirt, to make it look a little bit more natural. But it's mostly a height map. And the height map generation, let's just call it version 0.2 or something. It's very, very basic. And it's probably going to stay that way for a while, but I want to make it at least photogenic enough that people are going to be like, yeah, this game's worth following. I want to know what this guy's making. Oh yeah. And you have to use a voice like that, of course, when you're streaming. Yeah, I got a big manly voice. Let's see. 3D space materials, PBR, very big manly voice, yes. So material albedo. So you grab your texture and you drop it here. Yeah, I think I might have selected the wrong mesh when I dropped that one. Let's just try that again. Asteroid. Material. Forgot about the spatial material. Thank you, Sam. Thank you, Sam. I'm glad you appreciate texture. Now, you'll notice this hasn't changed color. I would have thought it would at least change a little bit, but no. And the reason why is this mesh. The reason why I believe is because this mesh hasn't actually got any UV maps. So we're just going to save this as, and we're going to put this in space in the materials directory. We're just going to call it gold asteroid, I guess. Gold asteroid, yeah. And while I'm here, I might as well just go through and set up the whole lot. RMA. So metallic is the second parameter, so I choose green, and then I go down to roughness, and I put the RMA texture in here again, and use a red channel, and then we've got ambient occlusion. We turn that on, although there's kind of no point because the map hasn't got any data in it for ambient occlusion. Then we go to normal map, and we put in the normal. I haven't turned it on yet. Put in the normal, and that's done. Okay, so we've got this material. Save. So the next problem we've got is that this mesh has no UV maps. So to add UV maps, I need to go back into Rust. Welcome back into Rust. And to collect myself. Okay, asteroid. When creating an asteroid, I call this function called trim.highmap, which is just getting more and more insane as time goes on. And here is where I create all the vertices. So I push my vertices, and I've created this builder. So a builder is a mesh builder. I've got one file that contains both the mesh builder and that gigantic function I'm going to show you. So the mesh builder creates a vector of UVs, and if that vector has data in it, we're going to pass them into Godot. So all we have to do is actually populate them. To populate them, I've got a builder a bit further down that you specify a UV as well. It looks ready to go. Let's just try it. Page up. Page up is not doing what I think it should be doing. It's because it's the enter button. Buy a new keyboard, ruin your muscle memory. Okay, trimmed height map. So here I want to push a position, but in addition I also want to push a UV. Okay, and the UV coordinate is basically, if I go back to my blender, so remember I made this box, and you look at these positions here. Where's my readout? Somewhere there's going to be a readout that shows me where my cursor is. Or I could try and count it myself, but that just seems lame. Yay for Blender being so incredibly useful and also incredibly hard to understand. Cursor location. Okay, that's what I was looking for. So when I move this around, yep, good. So this position is 0.2, 0.8. This position is 0.2, 0.2. Hi Ed Swordsmith, nice to see you. Thanks for dropping by. I need a lerp function. Function lerp. What if there's a lerp function already inside of Rust? I'm just setting up UV maps here. Thanks for dropping by the way. So I want to lerp from A, which is a float 32, to B, which is a float 32, and we lerp by X, which is also a float 32, and we return a times x plus so we start at a, then that means we return a times 1 minus x, and it needs to be 0.0 plus b times x. So as x increases, we go towards b. Great. And then I want to push in UVs. So the UV for x is going to be based on the x coordinate, and it's going to be from 0.2 to 0.8 using and to lip from 0.2 to 0.8 using x as fc2, and then the same thing. So those are the numbers I just read out of Blender as being my UV coordinates for y, and that should mean the top of the pillow has got UV coordinates that are similar to the inside of that box in Blender. Now, how to go down the sides, that maths currently escapes me a little bit. Let's see what's wrong with this. Oh yes, so UV takes a vec2, and so let's provide one. There we go. Oh, I'm not imported the vec2 yet. Great. And something else is wrong. What's wrong now? Lip doesn't return F32. F32, and I put a semicolon here. Okay. We're probably almost here. So that's the location for the UV coordinates of this. The next time we push a vert though, which is part of the skirt, we're going to need to provide some more coordinates. How are we going to figure those out? Okay. So we've got below left. Let's just be very lazy here. So if I look on Blender, the left side on X is 2. Yeah. I'm just going to be really lazy and just always set these to dumb values. So 0.2, 0.2. So we add UV coordinates there, and here, and here. So the texture to the side of the asteroid I'm going to do a lot better than this. But unfortunately the maths is, I don't want to do a bunch of maths in front of you guys because it will not work out well. You can see my code is so elegant and tidy. Isn't it gorgeous? Aren't you blinded by its simplicity and beautifulness? General veracity, consistency, concisity. Okay. Now we're creating loops as we go down and down the asteroid. So, you know, in my head, showing you this part was going to be like a really cool way of you understanding procedural generation, but the longer I look at it, the longer I realize that you will never understand. Do the go.rust binaries not provide equivalent functions? Yes, they do provide the same functions as the GDScript API. However, if you looked at how pushing vertices into the GDScript API actually locks a mutex and resizes one by one, you'd probably write your own API on it too. Okay. Yeah, that's true. So my game's not written. It's all Smith has pointed out that the way I'm coding is not written directly against Godot. I write my own simulation separately, and then I bind it to Godot. So Godot's kind of like a UI for me. I don't want to integrate super deep. And part of the reason why that's important is because I need to run on a server that's pure Rust. There's no Godot on the server. It compiled okay, but it didn't successfully. That's my Discord, by the way. You should totally join that. Just Google my name, you'll find lots of links to it. here's Godot running, and because it's running, it's holding open the DLL. I couldn't build for that reason, so let's build it again. That's cool, Null Pointer. You should totally join the Discord and show us what you made. There's a bunch of people on there who aren't making games using Godot and Rust, but they're making cool games as well. Like Sam, for instance, is using C# as well, and ProcGen, and he's making an amazing looking factory game in the fantasy world, and he made a very appealing video of his ProcGen recently. Okay, so the difference here is that we've now got UV mapping, so I'm hoping if I had a material override, and I just so happen to have one here, that we might get something. Okay. Let's try selecting the asteroid this time. No. Well, that was frustrating. Could it be because I never actually coded the code that would pass the UV in when making the mesh? Let's have a look. That's done somewhere else. So if I go into asteroid, the trimmed height map function is what we just looked at, and it creates this thing called a builder. And down here we use builder into to turn it into something called a rendered mesh array, and that calls this function called add surface from arrays. Yes. Oh yes, so the variant array is created somewhere else, so it was creating this rendered mesh arrays that was important. Oh. Okay, so we're going back to the mesh builder, and we're looking for a from. Here we go. I just wanted to check that, yes, it is actually trying to put the 2D UVs into the array. I wonder how I can confirm that there are UV coordinates in this mesh. Sam's linked the Discord. Thank you, Sam. Thank you, Ed. I'm glad you're enjoying watching me struggle. Geometry. I wonder how I can prove. Get a bit pissed off by the background constantly catching my mouse, so I'm just turned that off for now. Wonder how I can. Oh, well, I'll be. Do you guys see this texture here on the asteroid? Okay, so it seems like I haven't scaled it particularly well, and yeah, that makes sense. Actually, now that I think about it, but that's still a good start. Yes, Sam's got the right idea. Progress. No, I forgot to scale this into a value between 0 and 1. The color's really bad. Is it because the lighting's really bad? I think it's just a problem with the lighting. I probably don't have enough white light in my scene to get a good idea of what this is supposed to look like. Anyway, to fix this problem, I need to quit out of Godot again, save and close. Go into here, go back to the generation stuff I just showed you, which is further up, page up. And this point here where I was saying X is F32, Y is F32, and no, that's not the right one. With these loops. These two here, I need to divide these by the total height and the total width. So X divided by height as F32. I'm just going to ignore the fact that there's a performance cost to doing this every single time. You know, there's an easy win here by turning these into multipliers instead of you find out they're reciprocal and then you don't have to do a division every time. You can just multiply, and also there's a ratio here. But we'll just ignore that problem. cone mapping. Yeah, I have got some. Yeah, I think I know what you mean, and I think I've got it turned on, but I'm not completely sure. One thing that bothers me about the light mapping in Godot is it doesn't wash out to white. So this side is what I was expecting to see. You notice how I've got the same UV coordinate for the entire side, so it looks really odd. Please don't worry too much about that. And the lighting is obviously really bad. So let's grab a second light and put it over here and make it larger and make it more powerful. And lift it higher up. Move it across. So we've got a golden asteroid. This is an excellent start. Okay, so remember how I said I was going to make shaders? We can actually make some shaders now. Fantastic. Now, excuse me, but this is actually the very first time I've done this particular process I'm about to do with you, so everything's going to go completely wrong. Let's see if I can do this. Convert to shader material. Okay. There's a shader. Ooh, and it has code. Actually, not too much code. So let's have a look at our shader material code. Okay, so the shader is a spatial type, render mode, blend, mix, depth draw, opaque, cullback, diffuse Berkeley, albedo, it's got a uniform albedo color, texture is albedo, specular, metallic, roughness, those are the different numbers that you choose, point size, texture metallic, metallic texture channel. So these sampler 2Ds are the textures that we've put in. Texture roughness, texture normal, UV1 scale and offset, UV2 scale and offset. For each vertex we're modifying the UV by the UV scale. So I could have fixed that problem I just showed you by changing the scale. Yeah, shaders! And then down here in the fragment shader, that's the pixel shader, we're just, if that made any more sense to you, per pixel on the image we're running this bottom one. So the UV stays the same, albedo texture. So we sample the color, albedo RGB, we get the metallic. So we're doing a dot product between the texture metallic and the UV. I'm sorry, I'm just trying to figure out what the hell's going on here. It looks like it's using dot to pull out whether it's red, green, or blue, etc. So for instance, let's just say I said it's not metallic, and well, I'm not going to do it with metallic first because it won't be able to tell. So we'll start with roughness. So let's say we say it's not rough at all, and we do this. Okay. Oh, I need a semicolon. So you see everything is now buttery smooth. You probably can tell it looks really shiny. Or we can set it to 1. It's really rough, right? And so I think given we know that roughness is always going to be red, we could have said here that it's .r like this. That's the roughness channel. So in the interest of simplifying this code so it's easier to work with, because I'm going to have a lot of parameters soon, I'm going to do that. So what I just removed was this roughness texture channel variable, so let's get rid of that up here. Now if you were here earlier, the reason why this is in the red channel is because when I made it in Substance Designer earlier, I assigned it to the red channel. So my texture, which is an RGBA image, has put these grayscale things into different channels. Okay. So for metallic, we're going to do something similar. This is in the green channel. For albedo, we'll find it in the A channel. I'm sorry, albedo, I was thinking of a different thing. So there's an option to multiply the whole thing by a single color, albedo color. Let's leave that in because that lets us have vertex lighting. This gives us vertex lighting here. Don't have ambient occlusion. Normal map, there it is. Oh, to do what I was hoping to do with these textures, I am going to need a height map. Height map is in the A. So I could just put a reading of height here. Float height, and it's in texture. And it's in the A channel. Great. Now what we could do at the end here is we could say albedo equals vec4, and we could say, you know, red is height. We just set them all to height actually. Even just doing that would set them all to height. Put a 1.0 at the end. I thought we could do it that way. Okay, so albedo is a vec3, not a vec4. Fair enough. I thought it had an A component, but I was mistaken. So, wow, they made a really cool shape. So the albedo you see here is from the height map. I was really expecting... Oh, I see. So I'm using the texture height map. And the texture height map, when I baked it out, didn't have real data in it. So this is how I can read back this particular texture. That worked fine. But when I baked this one, I didn't put a good height map in. That's going to cause problems for the blending that I'm hoping to do later on. Anyway, that was just a way of showing that I can debug variables like this. So back to our regular color. Why does it look so bad? Probably just too bright. Okay. Albedo texture, albedo height, metallic, roughness, specular, metallic, roughness. So these values here allow us to adjust the specular and metallic for the entire asteroid. Do I still leave those in? I do. Here we are, being multiplied here. So we'll put them all at the bottom. Metallic roughness, specular. How is specular calculated? I don't know. I think it's just using the same number for the entire thing. It's using a constant. Metallic texture, roughness texture, height, albedo is from the texture as well. Okay. So what I wanted to do is change some of the names of some of these things. So we've got texture, alb, gold, right? Or res 0. So we could just call this res 0, 0, albedo. That's correct, Sam. That's correct. And so part of the reason why is because they are making it flexible so you can use both ways of doing this. So we're going to use res0 albedo, and as we go down here, we're going to sample the texture for something called res0 albedo. And so now we've got the height, now we've lost the color, but we've still got all the other data. So the shader is working, and so if we want the shader to continue working, we need to go into the shader parameters, and something here I've called res0 albedo still needs the same PBR material and flat for gold or base color like this. So as I rename each thing, it seems like I have to drop the shade, drop it in again. So let's just go through them all. So I'm making resource zeros. The plan is, after I've made a bunch of resource zeros, I'm going to make some resource ones, and we're going to do some blending. So resource 0 albedo. Now we don't actually need to keep texture, metallic, roughness and normal. We just need res 0, and it's roughness, metallic, albedo and height. So RMAH. That's the kind of texture we're working with here that we're getting from Substance Painter. We don't need to remember a texture channel. I don't think we need a normal scale. Now there should be some. Where is my sampler for normals? The normal map. How are we getting normals? Have I just deleted the texture normal in my process of deleting everything? Yeah, I did. Okay, that's good. So we've got an albedo one for RMA, and so we'll call this res 0 normal. So for the normal map, we'll put it here. For the RMAH, we'll put it here, here, and here. And then for the that's it. That's the res 0 done. Don't need to have this texture channel thing. There's all this scale and offset stuff. I'm going to ignore that for now. Well, that was pretty painless so far. And in order for this to look correct, I'm going to have to select the sky again and drop in. I've probably missed a couple of these textures here. RMAH is now missing, so we'll grab the RMAH texture and put it here. We'll grab the normal texture and pop it here. And we now have our fully gold asteroid again. Now, let us create a second one. So what I'm going to do is I'm going to create another sampler. We're going to call this res 1, 1, 1. Now, I'm going to have to come along later, and I'm going to have to figure out how to decide whether I want 0 and 1, but for now let's just use UV coordinates because that's a very easy way of doing it, or even might be cooler if we use the Z coordinate. I wonder if that's normalized. So I believe that we can add a varying, yep, and we can call it a float. We can call it res 2 or res 1, and then inside of the vertex shader we can specify that res 1 is equal to, I think it's position dot z with a semicolon. Interesting how it's made everything black. I don't understand how making a res 1 makes everything else black. Okay. I was going to say then albedo equals that, but I think I've done something wrong. What about Y? Can I get Y? Have I broken it by not... Have I turned off the lighting somehow? Okay, now it's all white. Why is it all white? And then black? Okay, I am confused. Okay, now I can't get it to come back. Maybe using position is off limits. Now, I expect this because I've turned off the albedo channel. Let's have a quick look at the other shader I made earlier. So I've already made a shader in the past. And it was in my experiments and first spatial shader. This was done using a tutorial. So, I can't claim too much credit for how amazing this looks. So this is a nice water shader that you too can make if you just follow the Godot tutorial on making your first spatial shader. Anyway, so let's have a look at the mesh and the material. No, we must have done it this way. So click on this again. Material, no. How do we set them? I probably haven't specified. Yes, I have. Why am I not seeing the material? Ah, there we go. There's the shader. And when we were creating the vertices, yeah, we use vertex.y and x. We didn't use position. Yeah, Sam tells me I need to make space waves. I'm not sure. I'm going to do something similar to make pretty things in space, like as backgrounds, but yeah, not so much. Probably going to use an effect just like this to make all the guns work. Oh, I'm going to have so much fun making this game. I'm so lucky I'm making games. I'm so glad I finally decided to stop putting it off and just bloody well do it. Okay. So res1 is going to equal vec.y with capital letters VEC, which I think is the position, and I was thinking that would mean that would get like white at the top and grey at the bottom. Now I'm actually having trouble deciding if that's working. Oh, it's not happy with vec. Is it VEX? VTX? I've already forgotten what the name of the variable was. Oh, it wasn't shortened, it was just the word vertex. Okay, fair enough. Of course. Nothing that even Tom could remember. Material. Great. Are we getting what I think we're getting? Are we getting y to the peaks? Let's just try reversing it to see if it flips. Oh wow, that's very funky looking, isn't it? Okay. So 1.0 minus this. Interesting. I wonder how you clamp it so that it's yeah, we learned how to clamp it during the tutorial. You'd think I would pay attention to that sort of stuff, wouldn't you? There was an option in the tutorial that let me just bring up the tutorial that was mentioned for it's like a little function that did selecting between two different values, and it was mentioned and probably used as well. Let's go to shaders, shading. Oh, it wasn't mentioned in here. Your first shader, it was mentioned in the shader book I was reading. So we'll look at the book of shaders. Yeah, the vertex heights are probably, it seems to be the non-normalized heights it's using, so the heights in world space coordinates as opposed to, so, they're probably like 2, 3, 4, etc. So I probably need to divide this by, 3 or something to get a number that's sensible. 0.0. Right? Or by 2.0. Yeah. Or I could use the z coordinate. Yeah, so the origin's at the top here, so it's divided by 15 or by 30. Wow, it's really interesting. I was expecting to see like a top to bottom fill. It's just getting darker and darker shades of grey without, it's like black on that side. I'm not sure if it's actually doing what I think it's doing. See it, what do I know what I think it's doing? Oh yeah, it seems to be lighter on that side and darker on that side. Probably be clearer if I turned off normal mapping. So there's the X position. There it is on the Y, which is up and down. Yeah, there's Z. Anyway, so the point of the book of shaders was that here around shapes, I think, nope, not even that far, it was mentioning a function that was drew a line, and this line function uses this thing called smooth step, and so the smooth step lets you choose two locations. Oh great. Smooth step lets you, let's see if I can click on it. Edge 0, edge 1 and X. And so edge 0 specifies the value of the lower edge of the function. So what it's saying is I should be able to goes between 0 and 1 between those two values. So if I was to say that res1 equal, if I went down here a bit further and I said the albedo is equal to smooth step, and we're going to use res1 as the input value, like so. We need to set two boundary conditions, so let's say we set 2.0 as the first one and 4.0 as the second one. We should get a stripe in our mesh that goes right through that particular boundary, and we'll move these into the space where the mesh is, because I think that that's in the top corner where there's no mesh. And we're going to use not Z, let's try using X. And I obviously don't understand what's going on in terms of the numbering here. Let's try 2. Okay, let's try 200. Okay, so that's not working. Is there an unlit viewport setting? That's a really good question, and that would be a great idea for Fulbright. Probably is. So I don't even know what values X is taking on in this. Let's try very small values for X like it is actually normalized. Yep, okay. So that's obviously this boundary between 0.2 and 0.8 is a carry in the middle here. I might just cut my losses and just call it stop there. So let's just call it blend factor. And so it occurs between where it goes black to where it goes white is in that location. And so just to once again hammer that home, I'm going to put blend factor down here as being the color. And res 1. Something's gone wrong with this. Why is it not happy at me? Okay, so I don't want a Vex3 for blend factor. Great. Now, I'm sampling gold. I want to also sample so we've got height 1. Let's call R1. So now I'm looking at the second texture. So this top one is R0. What if we can, oh, it's a shader, you can't really do R0. Now the correct way to blend between these two textures is to actually take the height into account, and so what you do is you multiply the height by the blend factor, and this is kind of a diagram with these slopes going to each other, which allows rocks to overlap, but we're going to ignore that for now. We're going to just do the basic version. So I wonder if there's a lerp built straight into shaders. But anyway, I want to say that metallic is metallic text. Well, we might just define metallic here again. So float metallic text is going to equal metallic text R0 times blend factor. This is similar to the lerp I was doing earlier, you see, minus blend factor plus text R1 times. Now I bet there's a lerp function. It's gone blue. Does it know what that is? I wonder if I could write this. Let's just try first. We'll just try first writing it like that. Yeah, I'm gonna write it with. I want to try and write a lerp like this. Let's see if it just magically works. Because I bet it will. So we'll want a lerp between this and this using this factor. And I want to know if, no, it didn't find the lerp. Max. Let's try max. It looks like you were right. Null Pointer Games, thank you so much for saving my ass on stream. Okay. So that has compiled. It's going to be very hard to see. So we're just going to do the same thing for albedo as well. So we got albedo R0, and we want albedo R1. We'll sample from 1. And we want albedo is going to equal albedo R0 and R1 with the blend factor. And apparently we defined it earlier. Okay, so albedo is the base color that we've been using all along. So we should call this albedo text, not just albedo. Now it's unhappy that we've assigned it a... Oh yes, we need to say there's a vec4, because it is that kind of texture. And then we've already got a metallic text, just going to ignore that for now. We're not doing roughness yet. Okay, so now we've got another problem, which is we haven't got any... we should be seeing half of this should look like gold now. Oh, it's because I'm still showing the blend factor as a debug thing. Yes, so you see we're blending from gold to nothing. And the reason we're blending to nothing is because I haven't actually even told it what the other material is. Material, PBR, flat, gold. So let's blend from gold to iron. So we'll drop the iron in here. Yeah, I know this is where you do this, display unshaded. Yeah, it's probably the best idea. Great, thank you for the hint. But it does look quite ugly. But we'll just go into normal for now. But it's there waiting for us later. Thank you for doing the research. I appreciate that. We're doing this as a team. Iron ore RMA would be this one. Iron ore normal would be this one. And now we'll move the blend factor. So we've got it from 0.2 to 0.8. Say it's from 0.2 to 0.3. It's a very tight band. So the blending is happening just in this little band here. Or we could even do it 0.4 like this. So you can see how we're blending from one to the other. The one thing that's quite interesting about the way that the shapes work in Substance Designer, and I was wondering how much we'd see it here, is that it kind of looks like these bands blend one into the other. Like this band goes into that band, this band goes into those bands. And so this is partially why, like this pattern is going around. This is why I was thinking it would be cool to, just use photos. Well, let's say we use a plain rock as the albedo and the plain rock as the RMA and normal. That looks a lot less like a space pillow now. Yeah, that's right. If we were to say that blend factor is equal to itself, can you actually raise it to a power right there and here, like this? Oh, now I'm trying to figure out where the power key is on my keyboard. No wonder my computer's got no power left. 2. No. Oh, it's complaining that I haven't said 2.0. Yeah, it doesn't want me to use that particular option, but this one might work. Seems to work okay. I mean, the reason why it's not sharp is because I'm using a wide blur area. If I wanted a sharp one, I could just use 0.21 and it would be very sharp like this, right? And I could say 0.25. Oh, you're trying to do an XOR. Yeah, that makes sense. Of course it is. So I'm actually this is going really well so far. So the next challenge on the board is to try and figure out how to I want to be able to mark certain vertices to have certain resources. So an asteroid might have multiple resources and then essentially has a resource patch. But I'm not sure exactly how I want to mark those. Like it still needs some brainstorming to figure that out. Feel like this is a really natural place to stop for now until I've done some more planning. So I appreciate that you guys have stuck around and watched me get this far. Thank you for coming along. I appreciate your viewership. Please make sure you follow on Twitch if you want to see more. Drop into my Discord. This is Recall Singularity. I'm making space factories in space. So there's going to be a lot more to enjoy soon. And thanks for joining me. Now I think I should try and send you somewhere else. How does one do this? Raid a channel. Let's see if we can do this thing. Who do we raid? Let's see if someone's doing something on a Godot. Yeah. I don't think any of this is worth doing. Okay. Thank you very much for joining me on Twitch tonight, and I hope you have a great day or night. I don't stream regularly at the moment, so the best way to catch up with me when I do stream is to see me on Twitch. Follow me on Twitter. My Twitter account is Recall Singularity. I'll show you what that looks like. So here's me on Twitter. It's Recall Singular 1. because my name is just too long for normal text boxes. And catch me on my Discord channel, where most people who you've been talking to here hang out as well. We're all making great games using Godot and Rust, having a fun time, and would love to have you come watch. Thanks for watching. Good night.